PracFinal problem 1. So to take the derivative of h of x equals to x to the 3 halves plus 2x over 3x minus 2. So we're going to use the quotient rule. So the quotient rule says we're going to do the bottom function times the derivative of the top. The derivative of x to the 3 halves is 3 halves times x to the 3 halves minus 1, which is 1 half, plus the derivative of 2x is 2, minus the bottom, so we did the bottom times the derivative of the top, now we have the top times the derivative of the bottom, which is just 3, all divided by the bottom squared. This particular problem asks us to find h prime of 4. So we're to take the derivative and then plug in 4. And the thing here is that to find h prime of 4, we really don't want to simplify this, right? You could simplify this, but really you should just plug in 4 right now. So h prime of 4 is going to be, let's see, I'm not sure, let's just do it this way. So 3 times 4 minus 2 times 3 halves times 4 to the 1 half plus 2 minus 4 to the 3 halves plus 2 times 4 times 3 divided by 3 times 4 minus 2 squared. If you were short on time on the test, I would leave it like that, but we can simplify this. So h prime of 4 is going to equal, let's see, 12 minus 2 is 10. 4 to the 1 half power is 2, right? The square root of 4. 3 halves times 2 is 3 plus 2 minus 4 to the 3 halves is 2 to the third, which is 8. 8 plus 8 times 3, all divided by 12 minus 2, which is 10 squared. So that's 10 times 5 minus 16 times 3 is 48, or it's 24 plus 24, divided by 100. So you get 2 over 100, which is 1 over 50. Okay, here's the second problem on problem 1. So the second part of problem 1, find g prime for this. So before finding g prime here, you really want to simplify. I'm going to write this as g of x equal to x to the 4th plus the 7th root of 5x squared. I'm going to write as the 5x squared to the 1/7. And although you could take the derivative, like when you do the derivative and take the chain rule, you do the derivative of the inside stuff, you could do 1/7 times this to the negative 6/7 times the derivative. Maybe we should just do it that way. I was thinking you might choose to write this as 5 to the 1/7 times x to the 2/7. No, I think we will do that. That does seem better. So let's write this as x to the 4th plus 5 to the 1/7 times x to the 2/7, all to the square root of 2 power. Remembering that 5 to the 1/7 is just a constant. I'll grab my eraser here. So then, taking the derivative, also when you're simplifying something, it is a good idea to still write g of x, right? You're not taking the derivative yet. So g prime of x is going to be, let's see, the derivative of this, so the derivative of some stuff to a power is that power times your stuff to the 1 less power. My stuff is x to the 4th plus 5 to the 1/7 times x to the 2/7 times the derivative of this stuff. The derivative of x to the 4th is 4x cubed. The derivative of a constant times x to a power is that constant just hangs out. So it's 5 to the 1/7 power times the derivative of x to the 2/7, which is 2/7 times x to the 2/7 minus 1 is 2/7 minus 7/7, which is negative 5/7. And I would definitely not simplify that. Okay, here's the third part of the problem. Find dx dy if x squared plus 2xy equals pi squared. So a couple things to observe here. First, We're finding dx dy, not dy dx. So we're thinking is x as a function of y, meaning the derivative of y is going to be 1, right, because y is the independent variable, and the derivative of x is going to be x prime, or dx dy. Also, pi squared is a constant, its derivative is going to be 0. So taking the derivative here, dx dy, I'm going to get, so taking the derivative of both sides, I should really say, the derivative of stuff squared by x is a function of y. The derivative of x squared is going to be 2x times dx dy. Plus, for 2x times y, we're going to use the product rule. The derivative of 2x is going to be 2 times dx dy times y, plus then we leave the 2x alone, and the derivative of y, since y is the independent variable, the derivative of y is just 1. Equal to the derivative of pi squared is 0. So then we're going to solve for dx dy. So I'm going to group these two terms on the same side. I'm going to bring this over to the other side. So I have a 2x times dx dy plus a 2y times dx dy equal to negative 2x, right? I brought that over to the other side. I'm going to go ahead and factor out the dx dy. I'm going to do it kind of the cheater way. I'm going to just erase it here and say, okay, I've got 2x plus 2y all times dx dy. And then we're going to divide both sides by 2x plus 2y. So dx dy equals negative 2x divided by 2x plus 2y. We can't cancel the x's here, right? Because you can't factor out an x from the bottom and the top. But you can factor out a 2 from the bottom and the top. So you can totally write this as negative 2x over 2 times x plus y, and then cancel a 2 here and a 2 here to get negative x over x plus y. That is your dx dy. And that's problem 1.